Students, good morning. I am so happy to see you once again through this CETEL YouTube channel. Today, I am going to provide a brief information on molecular diffusion. Molecular diffusion is concerned with the movement of an individual molecule through a substance due to their thermal energy. Molecular diffusion is nothing but movement of an individual molecule through a substance due to their thermal energy. Due to their thermal energy. Kinetic theory of gases provides a means of visualizing what occurs. Kinetic theory of gases. Theory of gases provides a means for visualizing what occurs. Kinetic theory of gases. Indeed, it was the success of this theory. It was the success of this theory in describing quantitatively about the diffusional phenomena. Kinetic theory of gases describes quantitatively about the diffusional phenomena. Okay, for a simplified kinetic theory, let us imagine a molecule is imagined to travel in a straight line. Let us see, this is the molecule. Consider this is the framework. A molecule is travelled in a straight line with an uniform velocity. Clear? This is the starting point 1, location 1. It tends to move in order to achieve the equilibrium, because assume that this is the region of higher concentration. This is the region of lower concentration. Due to this concentration difference, a molecule tends to move. A molecule is imagined to travel in a straight line with a uniform velocity. Straight line with an uniform velocity. The direction and velocity, uniform velocity. The direction and velocity will be changed when it makes a collision with another molecule. Say for example, during its movement, another molecule come and make a collision. Upon this collision, its velocity, magnitude of the velocity as well as direction will be changed. So this direction. Again, one more collision from this side. So its movement, the direction as well as velocity will be changed. The velocity changed depends upon the opponent molecule, how fast it come and make the collisions. Moreover, the direction will also be changed. Both magnitude of velocity as well as direction will be changed when the molecule makes a hit or collision with another molecule. Clear? This is the another collision. Here one more collision. It moves like this here. So what about the distance travelled by the molecule? What about the distance travelled by the molecule? This is the segment 2, location 2. Clear? Right. Say for example, this is distance 1 centimeter. Again, this is 1 centimeter. This is 4 centimeter. Assume that. Simply assume the distance. This is 5 centimeter. Clear? The total distance travelled by the molecules. So 1 plus 1, 2, 2 plus 4, 6, 6 plus 5, 11 centimeter. This is the total distance travelled by the molecules. Between the number of collisions, how many number of collisions? This is 1, this is 2, this is 3, this is 4. So 4 number of collisions. 4 number of collisions. Distance travelled by the molecule between the collisions. This is called as average distance. This distance is called as average. This distance is called as average distance. This distance is known as its mean free path. It's a mean free path. Mean free path. The average distance travelled by a molecule between the collisions is called as mean free path. Clear? Next, the velocity depends on its temperature. Velocity. The velocity depends on its temperature. Okay. What next? This is location 1, this is location 2. Here the concentration is high, here the concentration is low. A region of higher concentration to a region of lower concentration. Clear? It tends to equilify. It tends to achieve the equilibrium. The molecule moves from this direction to this direction. Now my question is, what is the distance travelled by the molecule in one direction, in this direction alone? What is the distance travelled by the molecule in one direction? This is the distance. Distance travelled by the molecule. By the molecule. Say for example 3 centimeter or 4 centimeter. So 4 centimeter. Time for this travel or movement. Time for this movement. Say for example 10 seconds or 5 seconds. So what I am trying to say is the distance travelled by the molecule in one direction. In a given time, distance travelled by the molecule in one direction with respect to the given time. This is called as rate of diffusion. This is called as rate of diffusion. Clear? So rate of diffusion is nothing but distance travelled by the molecule in one direction in a given time. This is rate of direction. The rate of direction can be increased by decreasing the pressure or increasing the temperature. Decreasing the pressure. Decreasing the pressure. While you decrease the pressure, what will happen? Decreasing pressure causes to decrease the number of collisions. Causes to decrease the number of collisions. Due to decrease in number of collisions, the rate will be increased. Rate of diffusion will increase with decreasing pressure. Rate of diffusion will increase with decreasing pressure. Decreasing pressure causes to decrease the number of collisions. First point. Second point, increasing the temperature. increasing the temperature. Increasing temperature causes to increase the velocity of molecule. Velocity of the molecule. So rate of diffusion will be increased with increase in temperature due to increase in velocity of the molecules. This is the brief information regarding molecular diffusion, that too rate of diffusion. One thing I am going to repeat. Molecular diffusion is concerned with the movement of an individual molecule through a substance due to their thermal energy. Kinetic theory of gases is highly helpful in describing this phenomena. Kinetic theory of gases provides a visualization what occurs. Moreover, indeed, it is the success of this theory in providing a quantitative phenomena of diffusion, quantitative diffusion phenomena. For a simplified kinetic theory, let us consider or imagine a molecule is imagined to travel in a straight line with an uniform velocity. The direction and velocity will be changed when it hits another molecule or a collision is made with another molecule. Both magnitude of velocity as well as direction will be changed. The total distance travelled by the molecule divided by number of collisions is called as average distance. This average distance is called as its mean free path. Its velocity depends on its temperature. What about the distance travelled in one direction alone with a given time? That is called as rate of diffusion. Rate of diffusion depends on temperature and pressure. You can increase the rate of diffusion by decreasing the pressure. Decreasing pressure causes to decrease the number of collisions. You can increase the rate of diffusion with an increasing temperature. Increasing temperature increases the velocity of the molecule. That's all. Thank you.